Milky Way's black hole is pictured for the first time, and it proves that Albert Einstein was right 100 years before. The black hole at the center of our galaxy, pictured for the first time in stunning detail. The findings show Einstein's theory holds up more than a century later after it was penned. The incredible image was taken by the Event Horizon Telescope, the same instrument that captured the first ever image of a black hole back in 2019. And the image basically looks the same. The team of more than 300 scientists have been probing Sagittarius A. It's an elusive region located at the center of our Milky Way galaxy. Since 2015 is when they've been probing. The European Southern Observatory ESO has shared its groundbreaking discovery in the world, and it announces a breakthrough at the press conference. EHT observational astronomer Sarah Isong said, "Today, right this moment, we've direct evidence that Sagittarius A is a black hole. It resides inside the dark region in the center of this image where gravity is so strong that light cannot escape." And she says we call this region the shadow, and is surrounded by very hot gases which we observe as the EHT. These radio waves create the glow. And this is not it, but that was a collision of black holes. This is the image of the black hole by ESA. Now, because the size of the black hole is proportionate to the size of its mouth, our image tells us that the mass is 4 million times the mass of our sun. It's really incredible, she says, that this prediction from Einstein's theory of relativity matches the mathematics. Sagittarius A, roughly 27,000 light years away from us, has been under the scope of astronomers for the last 5 decades. Its event horizon, the boundary around the black hole, where nothing can escape once crossed, has a radius of about 6 million kilometers, but it's buried by all the gas and dust of the Milky Way, making it harder to spot than the black hole observed at the center of Messier 87. And this is it right here. It's huge. This is Messier 87 black hole, as you can see. It's huge compared to Sagittarius A. Now, that previous object, also snapped by the same team, was more than 1,000 times bigger at 6.5 billion times the mass of our sun. But while the two snaps may look similar, side by side, experts have already noticed differences. They're theorizing what these differences could mean. Professor Ilya Mandel from Monash University in Australia said, "General relativity passes again with flying colors. One very interesting result is a very significant variability in the image. None of the models considered by the EHT fully explains this variability and some of the other features in the data." He says this is extremely interesting and may point to further physics of magnetized accretion disks that we have yet to understand. The holy grail for astronomers is now directly to observe the immediate environment of an event horizon. These observations offer the best way to probe directly the strong gravitational effects that are experienced under the regions of space-time. This, according to experts at ESO, say, will open new avenues for testing general relativity. Black holes are the products of the famous theory developed by Einstein between 1907 and 1915 on how gravity warps the fabric of space-time. Dr. Mark Norris from University of Central Lancashire of the UK said that the German's theoretical physicist theory could break down at this point. He said physics has done this amazing job of describing the entire universe in terms of 4 forces of nature: gravity, electromagnetism, the strong and weak nuclear forces. The problem is, he says, 3 of those forces, the electromagnetic and the strong and weak nuclear forces, he says the problem is 3 of those forces, the electromagnetic and the strong and weak nuclear forces, can all be described by one law of nature, and that is quantum mechanics, or what we call quantum physics. Gravity, he says, cannot. We can describe perfectly what it does, but we cannot describe how it does it. So there must be gravitational law that fits quantum mechanics, and the problem is, on Earth we don't have access to the extreme gravity needed to probe the limits of Einstein's gravity. It works perfectly as far as we can tell, he said. He explains if you go to the most extreme gravity you can get, that is a black hole, the laws of physics start to break down and the clues start to be seen. The great hope, he says, is that those clues, signs that Einstein's gravity does not quite fit, will lead us to this new improved theory of gravity that's compatible with quantum mechanics. Dr. Norris is a senior lecturer in astrophysics and has said such a breakthrough would be revolutionary. He said it would be the final theory of everything, a single law of physics that describes all the forces of nature. And with that discovery, Einstein's law will need to be edited, he said. Newton's law works perfectly well in the solar system up to the point that you get to Mercury when gravity gets too strong and you have to switch to Einstein's description, he says. And he says it's just a more complicated, more accurate description. Whatever law of gravity we come up with still has to reduce to being just like Einstein's law and just like Newton's in the way they have been tested. It won't be revolutionary in that sense, but it will allow us to make gravity work in extreme conditions. This is on Express UK, the latest about the ESA black hole image by Callum Hoare. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.